Hello, welcome to video number 80. It's an epic moment. We've reached 80 videos. This video is titled More About Binomial Models. And it's actually a very short model. We're going to do a little review about what the binomial model is. Then I want to discuss how to use your calculator to calculate probabilities. Okay, so here's our first example. Suppose you're dealt 4 cards with replacement. Okay, and let x equal the number of spades you get. So x could actually only have 5 values. X could be 0, 1, 2, 3, or 4. Okay, now 4 cards are dealt. This is the number of trials. So usually n represents the number of trials. So n is the number of trials, which equals 4. P is the probability of success in each trial. The probability of getting a spade is 1/4. Then, the probability of failure is 3/4. Okay, so we want to find the probability that x equals 2. 2 of the 4 cards are spades. Well, we're going to kind of do this from scratch again. So let's start writing out the possibilities. The first 2 cards could be spades, and the last 2 cards are not spades. We could have a spade, not a spade, and then not a spade. We have a spade, 2 cards that aren't spades, and then a spade. That's 3 ways it could happen so far. These are 3 different outcomes. All right, well, then we could have the first card's not a spade, 2 spades and not a spade. We could have first card's not a spade, spade, not a spade, and a spade. And finally, we could have 2 cards that are not spades and 2 cards that are spades. So there are 6 ways this could happen. Okay, we want to multiply this by the probability of each one happening. So each one has the same probability though, fortunately. So the calculated probability of x equals 2, it would equal 6 times, well, probably that 2 cards are spades, so it'd be 0.25 squared times the probability that 2 cards are not spades. So the number of ways it could happen times the probability of each one. And if you do this, I think you end up with 21.1%. So approximately 21% of the time, you'll get 2 spades. All right, let's find the probability x equals 3. Now, we're going to take the shortcut. The number of ways this could happen, remember we said was we could use combinations to find out. We could use 4, choose 3. So let's figure out what 4, choose 3 is. We're picking out which 3 cards are going to be the spades. How many ways can we pick 3 of the cards to be spades? So remember we did this on your calculator. First you have to enter the number of things you're choosing from, 4. We gotta turn it on, 4. And then we go math, probability, NCR, and we'll do 4, choose 3. Okay, there are 4 ways to pick 3 things from 4. So there are 4 ways. Okay, so here we go. The probability that x equals 3 is going to equal 4. 4 ways it can happen. Then times the probability of getting 3 spades, 0.25 cubed, times 0.75 to the first. If you do this, you get about 4.68%. This is the way we did the jury problem the other day. So we multiplied the number of ways something could happen times the probability of each one. All right, then we always want to know the expected value, variance, and standard deviation. The expected value for a binomial model is given by n times p, the number of trials times the probability of success. So there are 4 trials. Probability of success is 1/4. If you multiply that, you get 1. On average, we expect 1 spade. All right, so let's calculate the variance. The variance of x is equal to np cubed, which would be 4 times 1/4 times 3/4, which is, if you do it in a calculator, 0.75. Then the standard deviation of x It's just the square root of that. And I'm just going to leave it as that. We can find a decimal if we want. Okay, so these things we've kind of already talked about. All right, now we want to show you how to use the TI-84 to do this. So in this problem, a computer chip manufacturer normally rejects 5% of the chips produced because they fail pre-sale testing. So in other words, 5% of the chips are bad that they make. Suppose the company randomly selects a sample of 50 chips. All right, let Y be the number of defective chips in the sample, and we want to compute these probabilities. Okay, first describe what N is. N is the number of chips selected, which is 50. So each chip that's selected is kind of a trial. The probability that we get a bad one, that's what Y equals, the number of defective chips. The probability of a bad one is 0.05, which is 5%. And the probability of getting a good chip is 0.95. Now, we're looking for bad chips. That's why this is kind of success. Getting a bad chip is kind of a success. It's what we're looking for. And the probability of getting something we're not looking for is 95. So there's N, P, and Q. Okay, we want to find the probability Y equals 1. Okay, well, we're going to use a calculator for it this time. So this is a binomial model. And so we're going to press second, distributions. And we're going to scroll to binom PDF. Press enter. Your calculator, probably if it's updated, the first thing it's going to ask is the number of trials. 50. We're selecting 50 chips. The second thing it asks you is the probability of success, 0.05. Then finally, the last thing it asks you is how many you're interested in. We're interested in one of them being a success. And it turns out that this is 20.2%. So 20.2%. Okay, let's find the probability of getting 2 bad chips. So we can use our calculator again. And we'll go second, distribution, go up to binomial, PDF. PDF is for, remember, when you want one value. Okay, kind of same thing. Enter 50, comma, 2. I'm sorry, 50.05, probability of success. And we're interested in 2 successes, the probability of 2 successes out of 50 trials. And it's 26.1%. It's a little bit more likely we'll get 2 bad chips. All right, finally let's compute probability Y equals 5. So again, second distribution. Let's go up, binomial PDF. And we're going to enter 50. For trials, probability of success is 0.05. This time we're interested in 5 successes, and that'd be 6.59. Or 6.6%. Okay, we're almost there. Just like the geometric model, sometimes we want less than or equal to a value. This is the job for binomial CDF, not PDF. C is for cumulative. So it's right by the previous command. All right, so we want to find the probability that the number of successes is 3 or less. Here we go. Second distribution. And go up to binomial CDF. Enter the number of trials, the probability of success, and how many successes we're interested in. We're interested in 3 or less. So there's a 76% chance that we'll have 3 or less. Okay, let's change it to find the probability that there are 5 or fewer defective chips. Okay, so call this back up. Let's clear all that out. Second distribution. Go up to binomial CDF. Hit 50, comma, 0.05. And we were doing 5, less than or equal to 5. All right, 96.2% chance. So it's a pretty good chance that we'll get 5 or fewer defective chips. All right, this last one, kind of tricky. Our calculator doesn't handle greater than. It only handles equals and less than or equals. So we have to use the complement rule. The complement of y greater than 1 is y is less than or equal to 1. So we can calculate this by going 1 minus the probability of y less than or equal to 1. Okay, let's do that on our calculator. So we are going to do second distributions, binomial CDF, and the same thing, 50, comma, 0.05, comma, 1. All right, that's probably getting 1 or fewer, and we want to do 1 minus that. So 1 minus the answer is 72.1%. All right, phew. So that was a workout, but we used our calculator for all of those. So GeoMet PDF, GeoMet CDF, binomial PDF, binomial CDF are kind of very similar. All right, let's compute the expected values and we're done. So the formula for expected value is n times p. So that would be 50 times 0.05. So let me see what that is. That ends up being 2.5. So on an average, we would expect 2.5 bad chips. And the standard deviation would be the square root of NPQ. So let me find that. All right, got it. So this would be the square root of 50 times 0.05 times 0.95, and I got 1.54. All right then, we made it. So here's today's journal assignment. A wildlife biologist examines frogs for a genetic trait that he suspects may be linked to sensitivity to industrial toxins in the environment. All right, so pollution is causing a kind of a problem with the frogs. Previous research had established that this trait is usually found in 1 out of 8 frogs. So 1 out of 8 frogs is kind of a mutant. He collects and examines a dozen frogs. Use this information to find the following. All right, so a little explanation. I want to make sure everyone's clear on this part. N is 12. He's picking 12 frogs, so that counts as 12 trials. He is looking for frogs with a genetic defect. So the probability of success is 1/8, the probability of getting a frog that has a genetic defect, and therefore the probability of failure is 7/8. In this problem, X is the number of defective or frogs with a genetic defect. So X equals number of frogs with defect. Okay, so use these values for NP and Q to compute the following with your TI-84. All right, so the first 3, PDF. The next 2, CDF. This is the goofy one you have to use the complement rule with. Then finally, compute the expected value, which is n times p, and the standard deviation, which is square root of NPQ. All right, we'll check it out in class. Take care.